Okay, so welcome. I'm gonna try to record this one. It did not work this Monday, obviously. It's kind of sad after a whole lecture to find that there was no record afterwards of it. But now let's try to capture this one. So today I'm going to give you some demonstration of how you can make your own objects and bring into Unity. Because I mean, Unity is primarily a game engine. It is not a digital content creation tool, or DCC. So you get a lot of references to different DCCs. So make your textures in Photoshop or make your models in Maya and 3D Studio and so on, and then bring everything together into an interactive experience within Unity. So today I'm going to show you how we can use actually two DCC tools. One is Blender, which is an open source and freely available 3D modeling and animation tool that is very useful in conjunction with Unity. And the other one is GIMP, which is actually an open source version of Photoshop. So the tools that we'll use today are completely free, and you can start using them yourselves immediately. First of all, I'm just going to start an empty, pretty much a new scene inside Unity. So I told you last time that the difference between projects and scenes. So now I'm actually opening up my old project that I had last week, but I have went into the menu and set simply a new scene. So I'm starting all over again here, and I can save that as a separate scene from my last demonstration. So this is a new scene, and let's just quickly get it sort of into a shape by getting the plane in there, getting the floor basically set up, and I'm going to scale the floor 10 by 10, so that it's a little bit larger than that. And then I'm going to incorporate the first-person controller, first-person character controller. And we saw this last time also. Here's the controller, and I can drag it into either the hierarchy of all of my objects or directly onto the plane here. So if I drop it onto the plane, that's where it's going to land. And I can adjust the position a little bit. So now it is standing there on the plane. There is a camera inside the first-person controller, so I don't have to use the main camera anymore in my hierarchy. So now I have the controller, the light, and the plane. And if I play it, then I should see the world, which is empty. And that's our goal, is to put something in the world that you create somewhere else. So I'm done on this side for now. Blender, I put this actually as one of the resources that you can get. Okay. If you go to the course wiki page, then at the bottom there are a few links. I will add to these links, but right now there's a link to the Unity game engine, and here's a link to Blender, and here's a link to GIMP. So you can go to these sites and download them. And here's the Blender download site, and this actually is available for any platform. Blender is a really cross-platform tool. Blender was, it's actually an amazing story about Blender, because it started as a commercial project. And there was a first commercial release of this project backed by investors. But the first initial release was not commercially successful, or didn't seem like a very confident business. So the investors backed out and said, okay, we're going to shut this down. It's not going to be returning our investment anytime soon. But there was already a fan base out there of the software. So the fan base, along with one of the programmers that is actually behind this originally, they launched a campaign to save Blender. And they managed to raise money. This is before Kickstarter, by the way. This is like way back. They managed to raise enough funds to buy the license from the investors to make it open source. So they basically bought the license and then freed Blender. It was a free Blender campaign. After that, there was something called the Blender Foundation that has maintained Blender, and it's now up to version 2.7. It's actually a full DCC tool with more than just modeling and animation there. You can actually do more things in it. You can, in fact, you can make movies in there. It's actually a non-linear editing tool as well. But anyway, so by Friday, when you come to the lab, you should have this installed so that you have the opportunity to make something yourself on Friday for the lab. So I'm going to start Blender over here. I have it somewhere down there. Where is it? Here it is. So this is Blender. And this is the main window. And it's, of course, very daunting to come into a complex program like this with millions of options and things like that. But I think many of these things will be very familiar to you from other tools. So I'm not going to spend a lot of time explaining the details of what is happening, because there's also tons of beginner videos that you can use to try to understand this a little better. But I'll still tell you a few things. So obviously we have the 3D view here into our scene. It's set up a little bit like Unity in that you have kind of like a project and you can divide it up into multiple scenes. So we are looking at one of the scenes right now. And we can build objects in this scene view, in this particular scene. And we have kind of a funny thing. Blender always starts with one object. Of course, you can just delete that object if you don't want a box. But it's kind of a funny thing, like, okay, here's a little bit of a start for you. So there's a box in our scene, and maybe we're just done now. We have a box. We can export the box, but maybe it's kind of boring. So what I'm going to show you is that this one thing that I'm going to show you is that we want to paint on the box. We want to put a texture on the box before we put it back into Unity. But I'm not going to do any more advanced modeling than just using a box, really. Okay, so this is a 3D view. As you can see, the scene contains the box, the scene contains a light source, and the scene contains a camera. Just pretty much like Unity. So this is our scene. One thing that you probably will want to do immediately when you go and start Blender is to change how the mouse buttons work. Like in your mind, like what is the button that you use to select things? Usually, like if you want to select the box, what button was I clicking when I selected the box on the mouse? The left button. I mean, that's our intuition, like that's what we're used to. Blender reverses this by default. So you go into Blender, you're going to select something, nothing works. And you get frustrated and you just leave. So before you leave, you should go into File and into User Preferences, just like any other user preferences. And look at the input preferences. Select with left mouse button. I already did this, so you can see that it's selected. But it is already, it's by default on the right mouse button. So do this, and then you're all set. Then everything seems to work a little bit more like usual. And you can hold in the middle mouse button to change the view, and you can scroll the scroll wheel to zoom. So all of these things work pretty much as expected. Okay, so we have an object in here, and we want to play with it a little bit. Around the view here are some areas, and this pane over here, this is the tool shelf. So on the left of this 3D view, we have all the tools that we can use to manipulate what's inside. And in Blender, this is the T button to toggle the tool shelf. There's also another shelf on the right-hand side that we don't see. This is actually another panel over here, but there's a little, you see the little plus up here? The little plus that is appearing here. If I click the plus, I get another shelf over here. And these are the properties of our view here. So this is like a property window for the view, the 3D view, and this is the tools. So using these two windows, I can sort of manipulate the things that I'm looking at. And then I can close both of them like that and just have the view. Okay, here's our box. But what can we do with a box? So in the 3D view here, there are different modes of interacting with objects. And right now we are in the object mode. This means that we are in a mode where we interact with whole objects only. So I could, for example, do something like create another cube, and here I have another cube, and I can place the other cube. I mean, I can make yet another cube, and here's another cube. So I'm selecting the different cubes now. This is the object mode. I'm dealing with complete objects. The object mode does not allow me to modify the cubes or actually like change the cubes in any way. So if I want to start changing the shape of a cube, for example, I need to drop out of the object mode and start editing a particular object. Let me now actually delete these objects that I don't want. I'm going to delete this cube and delete this cube. I'm going to select this cube and change the mode to edit mode. Now I'm in edit mode. And now, of course, if you have the background in computer graphics, you know that like in 3D models, that the representation of 3D models is a set of vertices that are connected by edges, and they make up these surfaces between the edges. There are the polygons that make up the object. So we are basically representing this cube on the surface only. How many vertices are there? There's 8 of them, and they are connected by these edges here. I can modify any vertex now. So I need to be able to select a single vertex, and I can do that just by clicking on it. So I can take a vertex like that, and I can change the position in space. So in a way, you could start molding your object by dragging the vertices around. Maybe having just 8 vertices is not particularly, you can't maybe create a very interesting object with 8 vertices. So you are actually able to also, see, where is it? If you want and do something more complicated, one of the tools here is a way to subdivide the object. So now, if I press the subdivide tool, then I created more vertices inside the cube. So I have more vertices to play with. So now I could potentially drag this one up here and make something like that. A little bit strange. Or I could even, take one of the panels. Actually, let me subdivide even more, just as a, here. This is a bunch of cubes in a way that I can manipulate. I'm only selecting the vertices, but what if I want to change the position of any of the polygons that are in there, whole polygons? I can go into the face select mode. So this actually is a very useful selection down here. This allows me to determine what happens when I select something. Am I only selecting the vertex, or am I selecting the entire edge, or am I selecting a whole face? And if I select, for example, the whole face now, you can see that now there's little black dots. Each dot represents a single face of a full polygon there. And I can take any face like that. I could do like this. Now I'm changing the vertices of that entire face like that. Or I could use an extrude tool here and extrude a face, and now it automatically created new edges to follow that face going out there. This is a very powerful modeling approach. You can probably create all sorts of very interesting objects from scratch just by extrusion. Just make start with your box, subdivide until you have a bunch of, okay, anyone play Minecraft? It's basically a mini Minecraft. You subdivide, you have a bunch of cubes, and then you can push and pull the cubes around using extrusion. So you can shape it into sort of what you want, and then there's your object. now I'm going to step back. So this is just to show you that you are dealing with vertices, edges, and faces, and you can manipulate them all in the edit view. I'm going to go back and simplify the object again. I'm just going to go Control Z to undo. Undo, 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 undo. Okay, we're back to our original cube. So instead of doing sophisticated modeling, I'm going to add detail through texturing. That's another way to just to add a lot of detail to your model. Texturing, again, with those of you that have done computer graphics, you'll know everything about texturing and how it works. But I'm just going to say a few words about it. So what we really want is that we want to apply color information to all sides of this cube. But we have this problem that the cube is in 3D, but a color texture is in 2D. It's a flat surface. So we have this issue. How do we use a flat surface to color in something that has this three-dimensionality to it? I'm just going to quickly right up here. We have this object, and we have a flat texture like this, and we want the color information on this to apply to this 3D object. We do that using texture coordinates or UV coordinates. And as you know, as I just showed you, the cube has vertices, has 8 of these vertices, and we can store information inside each of these vertices. Actually, Blender will do it for you, so you don't have to really be exposed to the vertices themselves in a sense. But any 3D file format is capable of storing all sorts of information at these very interesting places in the model. And one such interesting piece of information is how, or basically where, this vertex gets its color information from a texture. Where should this vertex go into this 2D map to look for its color? So I can, for example, if I say that I'm going to color in this pixel here, and that's going to be the color of this vertex, I just take the coordinate of this pixel, which could be, I don't know, 5 this way and maybe 40 this way. Then I store 5, 40 as a texture coordinate in this vertex. So when this cube gets rendered and we actually get to this point in the 3D rendering, it will check to see, is there a texture coordinate associated with this location? Yes, there is a texture coordinate. Okay, what texture does it refer to? It's this texture here. Okay, I'll go with 5 in here, 40 here. That's the color, and I'll put the color right there. I'm going a bit fast because there's a little bit more to it to change the 3D object into pixels, but this is roughly it. Now, this vertex could actually get its color from somewhere else. And so let's say that this other vertex will get this color from over here. And that might be maybe that's 40. Let's say that this is 40. This one is getting its color information from 40. That's a different place. So I can go around the cube like this and just assign them different places in this 2D map where to get its color. And then the smart thing about all of this is that the rendering engine that is finally showing in this cube is going to fill in the blanks. If we give texture coordinates for the vertices, what's going to happen to these areas of the cube that don't have any vertices? It is simply going to do a linear interpolation between the texture coordinates in this and the texture coordinates in this vertex. So it's going to basically find the colors in between the dots there. So it's going to walk this way here and see, okay, I'm now 50% of the way from this vertex to this vertex. That will land me about here, and I will read the color from that location. That's roughly how texture mapping works. You just apply the texture coordinates to all the vertices, and then that gives you a projection from this space into this space, and vice versa. Okay, that's a technique we can use. But now, any idea what this map ends up looking like? If we have a cube and we want to project all of the different vertices onto this two-dimensional texture, what is the cube going to look like on this 2D sheet of paper? How do we know where to paint the colors? Where exactly? We need to find a way to, well, the process is called unwrapping. You can unwrap the surfaces of this cube onto a 2D surface. If you unwrap it, make sure that all the vertices get laid out in a flat plane like this, then we have come up with a solution that allows us to color all the vertices and all the faces of this cube using a single map. So this process of unwrapping is a really cool, interesting process that does this type of assignment of coordinates for us. And a tool like Blender is capable of doing this type of unwrapping. It's able to do unwrapping from any 3D object onto a 2D surface. So we are going to ask Blender to do this. We are going to ask Blender to make one of these textures for the entire cube. But can we help Blender to do unwrapping? If I ask Blender, well, we can actually, I don't actually know what happens. I'll just try it. Let's. So in Blender, when you want to have more than one view, you can always split views by going into this upper corner here and drag the corner to the side. Now I have duplicated the view like that. There's no point in having two 3D views here side by side. This at the lower left corner tells you what is inside the view, what is inside this window. So if I want to change what I'm seeing on this side, I can just go in here and see the different views that I can play with. I'm going to do the UV view. This is actually a view of this side. It's a 2D view of possible any texture map that I might create. I'm just gonna.
More than one view.
So yes, you can have any number of different views. Oh, it means more than one texture.
Yeah.
Yeah, you can select. There's a menu here of all the available textures that you're working with. So you could have layers even if you want. I'm just gonna do here select. Okay, this object is selected. I'm gonna do unwrap. Okay, maybe yeah. Okay, I'll try it. Okay, I did unwrap. What happened? What it did was that I took each face of the cube and unwrapped it into our 2D pane here, but it stacked them all up. It is actually making me responsible for, see, it's here all the vertices. Okay, it's kind of a mess, basically. It's a huge mess. It's really bad at doing this all by itself. But why is that? If you're trying to unwrap a cube like this, how would you go about doing it? It is a 3D surface. All sides are tied to each other. They're all stuck together. Can you actually, how would you go about making this cube into a 2D flat object? If you had this cube as some kind of a paper mache or something, you would start cutting it with scissors. And where would you cut it if you wanted to try to flatten it out? Yeah, you would pick maybe a few edges. You might stick inside one of the corners and then cut along a certain edge. You might cut around here, and then all of a sudden you can open this up. See, if you actually cut this, you cut down here, cut down here, cut down here, you can flip this open. And then if you continue cutting here and here, you can flip this one open. And you go on like this, and all of a sudden your 3D cube is now just a flat paper. So I didn't give Blender any information about where to cut. So Blender is just, oh, I'm trying, but it's kind of a mess. Blender allows us to tell Blender where the best cuts are. So to make the unwrapping easier. So here's what. So this is a kind of a crucial step before being able to do the texture, is to help Blender to unwrap the cube by marking what are called seams in the object. Here's our object again, and I'm going to change into an edge selection mode, this mode here. And even to make it a little bit clearer, I can even go into, here's the different kind of what we see in this window, what kind of rendering is being used. And I can even go into a wireframe view. So this is a wireframe of our cube. And because I'm now doing edge selection, I can select any edge on the cube like that. And now I'm going to select the edges along which Blender should cut when it unwraps it. Maybe you can help me. Okay, let's start with this edge. Oops, I'm not going to take it away. Here, so which one should I cut next? So we try this one and this one. So now if we cut along these and we leave one edge solid, then we should be able to open up this flap there. Some other ones that we should cut. I suppose we can do the same thing at the bottom. You can do this, and this, right? Now this side has sort of become like the center, and then this flops out, this one flops out, but this around the edges like this is still all connected. So we need to make one more cut to loosen up what is going around this way. So we should be able to cut just anywhere, like here, for example. So if you look at this cube, are you now able to mentally see how you can unwrap it? Let's see if Blender agrees with us. And we can go into mesh and edges and mark seam. And now when I unselect, I can see the seam is now all red, like that. Now I'm going to, again, try to use unwrap, just like I did before, but I didn't have the seams then. Let's see what happens. Look, perfect. This is now a projection of our cube onto a 2D surface. And I think we can even see how it is laid out. If I select one of the, let's see, if I select one of the edges, no. If I select one of the faces, yeah, if I select one of the faces, I can see where it maps. So that face of the cube maps onto this square on the 2D texture there. So these four vertices map onto these four areas of the texture. Very nice. And I can actually, in this view here, I can select everything and I can actually scale it a little bit if I don't want to use the full area. I can put it in the center like that. So I can actually manipulate this just like an object, in fact. So I have this. And let's go into this mode again. I'm going to go to object mode. Well, okay, let's actually save this first. I'm going to now save the UV layout. In the UV menu, I can go into export UV layout. I can export this as an image. And that's our starting point for modifying it. So I'm exporting the UV layout. It gives me tons of places to put these things, but I'm going to put it in courses, view, demos, assets, VIEN, props. This is a PNG image. I'm just going to save it as mycube.png. So that's the texture. I'll export it now into this folder. And notice that I'm exporting it into my Unity assets folder. So I think it's done, right? Did it do that? Okay, it's done. It's done. So Unity, when we created a new project, we gave it a folder to start the project in. Inside that folder, Unity created a folder called assets, and everything in here is in that folder on your hard disk. So if we actually go there on the hard disk, and you go here now. So this is this is it. This is the project itself. Then you go into assets. I created a subfolder in assets called virtual environments, and inside that I created another subfolder. I created the subfolder called props, where we could place stuff that we make. And there's the texture that I just saved, mycube PNG. I had not saved the actual cube itself, so why don't we do that also? We can go back into Blender, into object mode, and we can simply do save. Save the current Blender scene. It remembers that I saved something previously in props, so I can go directly there, like just by selecting props. And I'm going to call this also mycube. Notice that I'm saving it in the native Blender format now. And I'm saving it into the same folder as the texture. Okay. Now, what to do with the texture? Here it is. I have this PNG ending associated with GIMP already, so I can just double click on it and it will open GIMP for me. And this is our texture. There's not much happening in the texture right now, but now we can do some stuff with it. I'm just going to do something very, very basic. So let's just fill it with some color, actually. You see that it created these lines and sort of the semi-transparent stuff. This is just to show us where those sides of the box are. But and it's nice to use it as a reference. You can choose if you want to actually have it in the picture in the end. But what I usually do is to keep this in a separate layer in whatever photo editing tool I'm using. So I just use so then I just fill in some other layer with color. For example, this one here, I can fill with a pattern, maybe this pattern. So I'm just filling whatever was underneath that. Sorry about the craziness of this pattern. Do a little bit more. I can use those lines to help me select things that are just the sites themselves. I'm going to do a little bit of. Okay, I'll shrink this selection by 5 like that. Select. Invert. So right now, what I'm just doing is that I'm taking the airbrush, and the airbrush I'm using with a white color, and I am just lightening up basically the edges of each of the sides. I use the selection mechanism to keep the inner parts outside the working area. So what I did was I used the magic magic selector, and I selected the insides of all of the cubes, and then I inverted the selection. So I basically selected everything outside the cubes, and then I shrunk or grew the selection to either go in closer to the insides or further away from the insides.
But you have to say that you give them 5 inch.
Yeah.
Well,
So okay. So the steps were I magic selected all of the squares, and then when they were all selected, I shrunk the selection by 5 so that I selected slightly smaller squares. So now they're a little bit inside the edges, and then I inverted. So now I have everything outside plus a little bit into each side. And now I'm gonna invert it again, actually, to get the squares again, and I'm going to shrink it even further, maybe by 7. So now I'm even further inside, and I'm going to now use a black spray paint to do a little bit of darkening of the inside of each of the squares. I mean, this is just a quick and dirty way to make it semi-interesting. I mean, I'm not really making any cool object. So, okay, now at least I have something here. And I can just now save. GIMP actually only saves in its own native format. And there's own native format, of course, nobody else reads it. So we have to use export to save it back as a PNG. So I'm just saving it back, overwriting the original PNG, replacing it, and exporting it. And now we go back into Blender. And now we have to load the new image into this view here. And we can do image, open image, my cube. Okay, there's the image. And now in this view, let's see if we're lucky. No, we're not lucky. Actually, I should have selected this first. Now this can always happen. Oh, I see. Wait, it has to be in edit mode. Like there. And now we can open it. There we go. Here's our object with the applied texture. Right there. And we can save our Blender file like that. And now let's see what happens when we go back to Unity. And that's to switch there. Okay. And we saved everything into our props folder, so we can open the props folder. Let's see what we got there. We got my cube. Okay, we got a my cube here as some kind of a construct, like an object. Let's try to take this and put it in here. Oh, look at that. I can place it. There it is. And it's already being lit properly inside the environment. So we have something to work with inside Unity. And the interesting thing is that these are all linked now. So if I actually do some editing in Blender and hit save button, that object out in the scene is going to change as well. Okay, let's see. Let's take a break at this point, and then after the break, after 5 minutes, then I'll just end this with showing a little bit of interaction that you can add to this cube that you've just imported. Okay, 5 minutes. Sorry?
When you can look around the object, scroll.
Oh, look around it.
Yeah, I mean,
I can. In here, you cannot. Oh, in Blender, you can. In Blender, you use the scroll wheel to look around like this.
But you have.
You can try
here.
Yeah.
Because I don't have it.
Yeah.
Like that.
Yeah.
You have to hold it.
Yeah, exactly.
Okay.
So Unity and Blender have different.
This is with selection, and I change it on the preference.
Yeah.
Because
exactly.
Otherwise it was.
Yeah, which is very unintuitive, I thought.
Because I'm not to get started with Unity. The free version.
Yeah.
It's
Tree is it's complete.
it's complete.
Yeah, everything we need. Absolutely.
And then if you want to reset because you do something that you don't know how you did it and you want to reset your workflow,
You mean just to
if
step
you
back?
start if you started to open a tab shell,
I'm pretty sure you can always see the screen is up here. Let's see.
now you split it into
This
you want to have
this
it,
is the yeah
how it is
up here. Up here you have the different working
yeah,
screens. So you can pick the working screen you want, and then you can also save your own.
because sometimes it is in window and there is a reset or but
Exactly.
okay.
Yeah, I think if I do this, well, okay. Default is this, okay.
How you do again with the right field?
Yeah, how do you make this one?
Yeah. Like I got the same one, but it looks exactly the same like the first one.
Yeah, okay. The button here down in the left corner
Yeah.
tells you what's inside. You can change what is inside using this menu here.
Which one is that field?
UV image,
Okay.
UV image editor. That's what's inside here. Yeah, there's a lot of, there's a lot of things in Blender, of course, that is probably best to learn from looking at a couple of videos, looking at the tutorials. There's a really good wiki book about Blender. You just walk through it and you get introduced to all the concepts. It's not so bad once you get, and it's like it has really, really cool editing features. For example, here's our cube, and let's say that I want to change the X, Y, Z coordinates all at the same time. I want to give them all, for example, the value 0 or something. I can use my mouse to drag across them all like this. Okay, now I'm changing all of them at the same time. And I can even drag across them. Let's see. Oh, you. Okay, if I hey, there, and I can give it a value. So now the number I type in here is going to be applied to all three windows, all three edit boxes at the same time. So so I can, of course, just like in Unity, I can transform by dragging like this with the mouse onto these handles. But I can also press the G keyboard button, and then the object becomes attached to my mouse. And now it's just the mouse that is controlling it completely. And I can lock down any of the axes and pressing the name of the axis. There are all kinds of neat features that make working with it very easy once you just get a hang of it. But I can't say that I'm any type of an expert. We already have some really good experts in-house, but I'm not necessarily an expert in it. I'm not, but sort of a functional knowledge. One thing that you'll probably end up doing is that you will maybe accidentally or just for testing, you drag this out again, and then you drag this out again. You end up with something like this, crazy windows. and there's no intuitive way to close them again. Like there's no close button or anything. So
problem.
yeah, exactly. Well, what the trick is, you use the same little corner to close, but you have to do it in a particular way. So in order to close this one, the only way to close it is to find a window that is exactly the same size and have that one go back over it. So in this case, I have to go into this corner of this one. I have to press and hold my mouse button and then drag it across over here with the mouse button still pressed. And then you can see the arrow. And then I release the button and it fills. Yeah, it's not intuitive. And again, I mean, the only way to close that one is I cannot take this one and put that one over that. I have to take the same size window and put it over. So if I take this one, for example, click, drag across, the arrow appears and I release. That's how you get your windows back. And finally, I can take this one, drag over this one, and I'm back with this view. Okay, so let's, yeah.
I was asking about that before.
You were asking about that.
Not that.
Okay, and I mean that's also a valid point.
Easy.
If you are into some kind of a crazy thing here, you can also always choose a layout that is already pre-stored. So like the animation layout looks like that, and video editing looks like this, and then you can go back to default. Well, okay, it saved my default. Ah, nice. Okay. So I guess, oh, you see, I'm already doing this. I have to click and go over it, and then I have to click and go over it, and then I have to click and go over it. Okay, we're back. That's our default view. So that's it for Blender for now. So I'm going to go back to Unity. This is our Unity scene. And I can go into the scene because we have a first-person controller, right? So we can actually walk around now. And you actually see that I can walk right through the box there. So it doesn't quite exist, I suppose. I can add a collider to this box. So if I select the box here, then I get all of the properties on that right-hand side, and I can go to Add Component, Physics, and a box collider that will construct like a solid fence around the box. It's a separate set of vertices. It's like another object actually. It's like another object that we chose to have the same shape as the original object in this case. So there are now two cubes sitting together in one place. One is called the collider object or collider box. And the collider object is looking for collisions with other collider objects in the scene. And if two collider objects collide, then something happens. And by default, what happens, let's just see what happens now if we go in here. By default, it blocks me. I cannot walk past this box. So now you already see a different behavior from before. In fact, it slides me off the box. If I go at the box at an angle like this, it just sends me past it pretty much. So this is a very solid box now that I managed to create by putting up a box collider on top of it. I'm going to do a little bit of interaction so that you see how. Yeah, go ahead.
What if you have more complex options?
Yes, if you have more that's a good question, because now a box obviously fits the box collider perfectly. So you have a choice between different collider objects. So you can see if you do here add component physics, you have a list of colliders. You have a box collider, sphere collider, capsule, mesh, and so on.
So you can build.
You can build them. You can build a collider object out of some primitives, or you can go all the way and find a mesh collider that has the same shape as your original mesh.
Can't you, is there no way to use the model from like any modeling software?
Yeah, exactly. Just make your create your collider in Blender and import that as a mesh you can put there. Yeah, so you can shape it any way you want, but you have to be aware of the fact that the complexity of the collider increases the load on your GPU probably rather than the CPU. This is actually additional calculations that have to be taken into account because they are constantly looking for collisions with other colliders. They want to do that check as fast as they can. If you have hundreds of objects, for example, in a scene, and they're all checking to see if any mesh of their mesh collider is colliding with any part of some other objects mesh, each object might be checking, I don't know, 50 meshes or something like that against 100 times 50 meshes at every step. I mean, this is like crazy.
It does Unity actually check.
No, it tries to be smart about these things.
Yeah.
But still.
So how, sorry to take a first,
Yeah, no.
how inefficient does it go? Like if you have extremely complex collisions,
I think you
does it
can.
affect performance at all?
Yeah, it does. I mean, it does definitely. If you go into some crazy scene, you want to pour a lot of objects into it. You're probably pretty good for most of the things you're doing. This is probably something that people are a lot more worried about a bit further back when there was less power, computing power. But it is sort of exponential when you think about it. So if it's so if you really so it's really quickly gets into a situation you don't want to be in, and you can profile these things. You can in Unity you can actually see where your time goes, and you can actually follow this particular computation and see, is my collision computation going way out of bounds? Then you should do something about it. But as a general rule, why not just be smart about it right up front? I mean, when you don't need to be.
I mean, if you have a complex scene, you need to create a collision by yourself.
That in itself is also a lot of work to make the right collider. So I would actually say that for try using pretty much only if you just use the box, sphere, and capsule, you are pretty much set for most cases. And the sphere, by the way, you probably know it already, the sphere is the fastest collider check there is. Because to see if a sphere is intersecting with something, you just have to do a comparison with the radius of that sphere and nothing else. There's no mesh, corners of a mesh to worry about. So if you can use a sphere to do that, the box collider is also fine. Like in this example, the box collider fits very nicely, but you could also use a sphere collider for the thing that we are actually thinking about doing next, which I'll show you. So what I wanted to do is, what if I want to be able to pick up the boxes? So I want to be walking around the scene, picking up boxes like that one. Now I'm thinking about some kind of a custom behavior. I mean, this behavior that you're adding here through the components, ready-made components, they are kind of like all prefabricated behaviors that act in the way that we expect them to, like the collider component. We just basically added it, and it's already colliding on all lights. But what if I want to do something a little bit special every time you collide with that object? This requires a script. If you want to do some custom behavior, you need to script that behavior yourself. And Unity allows you to script behaviors using C# or JavaScript, and then that other strange language that is sort of Python-like, but no one uses. But basically, C#, JavaScript is what people use to script behaviors of objects in Unity. So in this case, I want to add a scripted behavior for this cube. And now I'm going to do like in the kind of, in Icelandic, the frontal classes when they come out here. I already did this at home. It's ready-made. Throw this thing that I'm trying to do it, okay. You may know the reference, like, are you familiar with these shows? Maybe cooking shows. They mix everything in front of you, and like, okay, by the way, then after 5 minutes, and they throw this out, bring this new thing out, it'll look like this, it'll be perfect. So I'm going to do that trick here. I'm not going to program the behavior on the spot here, because I already programmed that behavior. I'm going to show you where it is, and then I'll explain to you what it does. So in our in my VIEN folder, in my project, I already had a folder called scripts. And so I open that folder there, and I see 3 C# source scripts. Oh, what happened to the... Was that? No. No, that's no problem. Okay. All right, we're back anyway. So here's a script, a small script that I wrote that is called Pickable. And it's basically a script that describes the behavior of being pickable of, by a player or something. And I can now, if I have my cube selected, I can take my scripted behavior and just drag and drop. I can drop it, in fact, on the object here, like that. Here you go. Just took the C# script, I tried it on top of that thing and dropped it. And what happened to it? Well, it got added to the list of components inside the object. So now we have the collider we just added as a standard thing, and now my little script here, Pickable, is now attached to it. And what does it do? If you open it, I can just double click on the script and it will open whatever editor that you are used to. I think it comes up probably with Mono Develop if you have not associated with other editors. This one I already associated mine with Visual Studio, so it comes out with Visual Studio Editor. So this is the script Pickable that I had previously prepared for this object. And what does it look like? It is a single class. So all of the behaviors that you want to develop and attach to objects, they're basically classes. And these classes, they inherit from mono behavior, which is the base behavior of any Unity object. So if you want to inherit the ability to be a Unity behavior, then you want to inherit from mono behavior. So now so just doing that, creating an empty class that derives from mono behavior, you already now have the basics of a behavior that may not do anything, but now it's your responsibility to fill it in. And any behavior can override these 2 methods, for example, the start method and the update method. Any behavior associated with an object, like if you go back here, anything on this side will get called at the beginning and allowed to do whatever code you have in there in the start method. So like if you just have something over here, you write something into the start method, you know for sure that code will run at least once when the whole scene gets up. So that's a way to get something, I don't know, generated or calculated or something like that at the very beginning. Then after things start up, Unity will go again into this list here and call every update method that it finds in these components. So any script that is associated with an object that overrides the update method will be called every single frame. And so your behavior that only has to then like just tell the system what to do every frame. And then you can do as complex scripting as you want to figure out what that exactly is. So those are these 2 methods, start and update, that you can fill in for any behavior. There's one more thing that you can do to get to do something, and that's to receive a message. And this method here, on trigger enter, is actually an override of a method that is able to receive messages from a collider. So I did not make this up. This is just a standard method for receiving collider events. So in this script, I have already built something inside this method. And this, obviously, this script here gets run every time that this component receive a collision event. And what does this script do here? You can see it a little better. Can you see what it's doing?
If the object doesn't collide is a player,
Yeah,
then sends a message pick up
yeah,
and simply log the collision with the player, just to you have the log information.
yeah.
And
Mhm.
then
And then basically it destroys itself. It just,
why?
because you're picking up the object from the world, so the world representation doesn't have to exist anymore. It turns into, well, actually, that's the goal of this behavior. It turns into just an inventory item for the player.
Okay.
So as soon as you pick up the object, it doesn't have to be rendered in the world anymore. It's just in your inventory. So yeah, it's a bit drastic, I suppose. I mean, it's basically self-destruction on a hit. But before it self-destroys, it actually sends a message to the colliding game object, which, if that colliding game object is a player, and sends it a message called pickup. So the player object with the correct script can receive a pickup message and do something with it. In this case, put the object in its inventory. So that's actually all we're doing with this. So let's go, but look at this. It checks to see if the colliding game object tag attribute equals player. We didn't actually create a player, did we? Just create a first-person controller. We didn't do anything with marking anyone as a player. And maybe we should do that so that this check will return true. And if you select any game object here, you will see that up there on the top property, we have a tag drop-down menu. You see a tag up there. If we do the first-person controller, we see it's untagged. We can drop down and say that's a player. It's kind of like a way to identify a class of objects that have certain function. So we can say this is actually a player object. So now we have marked this as a player. So hopefully now that check is going to return true if the player walks into the collider. The player, well, actually, let's just try this now. You'll actually see what happens. First of all, I will show you what happens when it does not work, because we will start now, and as you will see, we will walk into this collider. It is still just pushing against us, not getting destroyed. Why is that? Exactly. Huh? It is not calling my script yet. What is happening is that the pickable is here, but what is, so I have the collider component here. I have my pickable script over here, but this collider is acting like a physical collider and just behaving like a wall when I hit it. It is not sending any trigger messages or collision events. What I have to do is that I have to turn this collider into a trigger. Sure. And this is important. I mean, a collider can have these two different functions. It can function as a physical obstruction, which is the default behavior, or it can serve as an alarm, a trigger alarm. So if someone crosses it, collides with it, it doesn't push against you, it just sends a trigger event. And I have to check this now. If I do is trigger like that, it will stop behaving like a physical object, and it will start behaving more like an alarm. Same bounds and everything. So let's try this again. Now I should be able to go. The object disappeared. It's gone. It worked. It destroyed itself. So it captured that trigger event.
So could you give us some example of behavior with this cube that you do?
Sorry, with what you would want Leno to do?
Yeah, like I mean, there is just one object, is a
Yeah.
the object, but
Exactly.
You can push it up. You can move it also.
You can, the moving of objects, yeah, you can actually do that by changing some of the properties, making this a rigid body object.
I mean, when you are going on it, you move.
Yes, exactly. And we actually had that in our last week's demo. Then we just had these objects come default with the physical properties of rigid bodies that you could manipulate and push around and stuff like that. That is already built-in behavior. You don't have to script it. But now I want to see what we can do with the script, because now we have something happening. We basically have this collider calling our script now, sending it an event, and we are picking up the event. But we see that we got an error message here when we hit the object. Pickup has no receiver. Why is that? Sorry? Yes, exactly. We haven't defined the script. We haven't actually added the script that was supposed to receive this event here. So in our trigger response of the box, we send the player this message. And let's see, the player looks like this. And if you look around here, the player object, there's no script associated with it. Luckily, I already prepared an inventory script. And we can take the inventory script and just drag it onto the player. And now it is here. It is here. We can open up the inventory script. And look here, we have a method called pickup. So this actually, sending a message with a certain name simply just looks for a method on that other side with that same name and then calls it. So now we have added a method inside this behavior that's associated with the player, and now it should be able to receive this. And it is what happens when it receives a pickup message is that it's supposed to play an audio clip and increase the inventory count by 1. That's it. I mean, it's not complicated. It's just increasing it by 1. There's nothing really happening. And I will show you. Let's see if it works. It expects an audio clip. You see up there. This is kind of interesting here. In any behavior in Unity, look at how these attributes are declared up there. They are declared public. Anything that is declared public in a class, in mono behavior, or in fact in any class that is a component, those things are going to become parameters in the inspector. So I say a public audio clip, public count. And in Unity, when I drag the script in here, these two attributes became available for you to edit. So now the developer doesn't have to know anything about scripting, just sees, okay, what do I have to do to make that script work? Oh, it wants an audio clip. Let's find an audio clip. I can click on this field here, take one of these, I don't know, there's lousy audio here, but I'll just take one of the jumping sound or something. Okay, so now I have found an audio clip to put here. Let's see what happens now. Okay, this is just me coming in. These are my steps. You heard that? That was that sound that got played when I collided with it. So that was this audio source play clip as a response to the pickup message. You also notice that there's a counter up there. Items in inventory 1 out of 2. So supposedly I could find other cubes to put in my inventory. So to make that a little bit more interesting, why don't we put more cubes in here? But remember that we already did some work on this cube. We put our Blender cube there, and then we added the box collider, and then we put his trigger here, and then we added the pickable script. We have done a whole lot of work on that specific instance of the cube. What if I want to make more cubes that have exactly the same behavior?
You can copy and paste.
I can copy and paste. That's one method. One really nice method to do sort of that for us is to store that object, now already edited, as a prefab in our project. So it's kind of like taking something we have worked on and putting it back in the box, in the toy chest, so that we can now reuse it and re-instance it. That's the most powerful way to do it. So
Copy and paste disappear if you are not here.
I mean, you could copy these things, make another cube, and then kind of copy these back into the other cube,
Yeah,
like
but
one by one. But this is the powerful thing. You can take something you already worked on up here, and let's actually just, well, I'm gonna add a folder actually here called prefabs. Prefabs. VIEN folder. Open the prefabs folder, which is empty. I'll take the cube, drag it, and drop it down here, just like that. I just took, because I've been editing that one, I just dragged it in here, and it pretty much made a copy of it. Just made a copy of all the properties associated with that one game object in its current state. And now it's like packaged. It's a little blue icon, it's packaged. And I can even take this one out. I can delete it, but I still have my neat little game objects prefab there. And what can I do with it? Well, I can just take it and put it anywhere I want. See, and each one of these has the box collider and the pickable script all set up. So if I have created something that I like, this is a very neat way of just storing it, and then I can use it as many times as I want. And we can now start this up, and I'm in a world full of boxes. And let's see if the behavior works. Okay, I got that one. Got that one. I'm even more than 2 now. I'm just still counting, 3, 4, and so on. So all the behavior works. So now we know about prefabs, because there's a really, really powerful building block inside Unity and used a lot. And sometimes you actually use other people's prefabs, just like the first-person controller that we dragged in here. It's quite a complex game object with a lot of components. Someone already assembled it for us and allowed us to bring it in as a whole object. So you will, throughout this course, you will probably create prefabs that you like. So I suggest doing something like this, have a whole project and then use your virtual environments that you create, store that in one folder, and you can always access it for the different scenes that you want. And now I can just save this scene. I can save it here as, okay, demo 2. I can always come back to it later. And I can now also build this. If I build, then I should always make sure that the scenes I built include the current one. So add current is that one. And then I can build this, but I probably don't have to. Well, and then I can go in here and just say maybe build folder demo 2. And here is the folder built demo 2. Okay, here's that simple game. Of course, that 2 over there that I set as the 1 of 2 0. That was actually just a fixed number. This 2. I mean, you could of course do a little bit of programming to find how many cubes there are and put that as the maximum number of cubes. A little bit about the display of that number. Look, I actually put the display of how many items in your inventory. This is inside the inventory behavior script for the player. And it's inside a method called onGUI. Just like the update and start methods, this is a fixed method already known. It's just you're overriding it. And this method gets called every time that the user interface is being updated by Unity. So it is refreshing all of the GUI layer on top of the 3D scene rapidly. And inside this, you'll place things like text that you want to display, and this gets recalculated. So I use the count here, put the current count as the new number. So this text gets appended with the number that is currently in the inventory, and this gets written out on the screen. We'll go a little bit later into the GUI system, and also maybe actually look at the newer GUI system that Unity is using. But this is enough probably at this point. So that's it. The last thing I wanted to cover, we have like 10 minutes maybe, or is the project, the first assignment. Let's see. So now, of course, on this Friday, you will do a similar lab. You will do your own kind of picking up objects lab. And for that lab, you should bring Blender so you can make an object. Bring some kind of a Photoshop-like tool, like GIMP or Photoshop if you have it. And then, if you like, maybe until the lab, you could even bring an object that you make at home. I mean, you could make something over the next day or two. Maybe make a texture or two. You can take pictures of things if you want to use real textures. So think of it like for the lab class that maybe what kind of an object you want to make. And then in the lab, you write up the code to make it, to be able to pick them up in the world. But we also have programming. Oh, I see. I didn't make the link yet here. So I will use this one here. Copy it from it has not changed since last time here. Programming. I'll just make it available right now. Programming 1. And so, okay, this due date is I'll update the due date accordingly. But it's going to be due in a couple of weeks, 2 or 3 weeks. I'll set it up in my school so that you see what it is. But the first independent programming assignment, there are 3 assignments. Basically, there's the assignment 1, assignment 2, and then the final project. Each one of these is completely up to you what the world is. You can make it completely from scratch. And you kind of want to build up a little bit of an atmosphere or a story around it. But the mechanics, at least you have to have those basic mechanics that I described. And in the first assignment, the basic mechanic is that you have props. There's a world, you can have any world you want, but in the world, there should be objects that you can interact with, or props that you interact with. And the interaction should be kind of clear. So the way I wanted it to work is that you're using the first person controller to walk around. When you come close to an object, when you're kind of in the vicinity of an object, that object should become selected. So you should show somehow in the object that it is now selected. To change some property of the object, maybe, make it move or change its color or something like that. Okay, so now it's selected. If you are if you have a selected object and press an action key, which is often the E on the keyboard, then something should happen to the object, like it turns on. So just imagine you have a television set, it's not selected, I walk closer to it, it gets selected at a certain distance, and then I press E, and it turns on and starts playing a movie. So that's a basic interaction with an object, a prop. And so for this first assignment that you have a couple of weeks to work on, build a world, put a few of these types of objects that you can dream up in that fit the world. I mean, try to tell a little bit of a story there. It could be an exploration environment, something like that. And just kind of go wild on what happens when you activate them. So maybe one last thing that it's useful to know, in order to make that happen, is just take a look at the collider again here for a minute. If I press Edit Collider like this, I can now actually change a little bit the size and shape of the collision object. And look at what I did there. It's kind of hard to know, but I increased the size of the collider object. It is no longer as small as the cube itself.
If you want to do it to all objects that you selected before, and
yes, so you can edit the prefab down here, or you can also, if you actually edit one of these, you can say apply. There's a little prefab, because actually
it's not possible to select all objects that you can select one.
I don't know, let's see. You can do this and then this.
Yes.
Well, it doesn't quite work the way you want, I think. So they're all selected, but I'm still just editing each face by itself. So you can change the shape of the collider object, which means that you can actually put a field around the object, a little bit further away from the object, to know when someone comes close to it. And often, if you're doing like how close someone is, it makes more sense to actually use a sphere collider than. Okay, and the sphere collider, where did it go? Probably went in. Okay, I see. Take the box collider out there. This is the box collider. This is the sphere collider. This is the sphere collider now. So make something like a sphere around an object and make that a trigger, and then you can have that trigger something when you come into proximity of the object within a certain radius, basically. Okay. And the other thing, yeah, go ahead.
Do we get that code for example?
As a template for this?
Or like get familiar.
Yeah, so in the lab, certainly, because on Friday you will make this yourself with the lab, and then that can be the basis for your assignment.
Oh, wow.
Yeah, so you will get eased into it in a way. And the last thing I wanted to point out was that to capture a key from a user, you can simply, I'll show this to you again later. So here I am inside the behavior of a single object. And if I add this code, for example, to the update method, which is checked repeatedly, I can check for user input. And if the user presses a specific key, then this code gets executed. So if I update it like that, and I go in here, and I play it, and I press E. See, I'm lifting the objects. E. They're all listening to the action key. And when they hear the action key, they increase their upwards coordinate. And this is just this one line here. Taking its transform and then adding a vector to the current transform. It's a little bit of an upward vector. So very straightforward. So I think you have everything you need to do the assignment, in fact, and then you just can kind of use your imagination to make it kind of interesting. All right, that's it for now, and thank you, and I'll see you on Friday.